Two Sigma, we're an investment manager down in Soho. We do almost everything we do. We use science and quantitative methodology. I should explain the TLA. I am not the Chief Information Officer or the Chief Investment Officer. I'm the Chief Innovation Officer, which more or less means I get to do what I want as long as we're pushing the business forward. And one of the things that I do is be on the lookout for things that I think are orthogonal and accretive to our business, and one of those is SigOpt. So I'm very happy to be standing up here with Scott and talking a little bit more.
Excellent. And one of the things that we love about Two Sigma is they're an extremely model-driven business. They think about modeling at every layer of the stack, which is exactly what we help teams do. In addition to Two Sigma, we work with a variety of other firms as well, a lot in the asset management space. So we can name firms like Two Sigma, but we work with several others with several $100 billion in assets under management, as well as your typical investment banks, retail banks, credit card companies. But it's relatively agnostic, the solution that we provide, and I'll talk about that in a second. So we also work with the US intelligence community, various tech companies, really anyone doing sophisticated modeling that's looking to get an edge.
So modeling is the key, and let me tell you a little bit about Two Sigma and what we do, and then you'll understand as Scott continues why this solution is a great fit. So this is actually a picture from our open source website. Two Sigma, founded by a computer scientist and a mathematician, really believes in heavily bringing the scientific method to investment management. And that really means, in the case of Two Sigma, that everything that we do is first grounded in a scientific method, whether it's modeling in our investments, or whether it's in engineering, a project that we do. And one of the organizations that I run at Two Sigma creates the platform for our modelers to express themselves. And we have a very clear and succinct vision for our team, which is not surprisingly called modeling engineering, and that is a conversational research platform. So we fundamentally believe at Two Sigma that the ideas that are sitting in the modelers' heads, the whole goal of our platform is to get them from somewhere in the back of their heads out to trading, for example, with as little interruption as possible. And that means that we seek to create a platform that will interact with these modelers in a way that enhances and leverages the human rather than supplanting it. So we are fully into AI, but AI, like the bionic man, maybe I'm dating myself, but helping humans rather than supplanting them. What we found is, not surprisingly, if you build a platform, then standing on that platform, you can just see further than you could have seen before. And what we found is that our modelers are able to ask questions, or even able to formulate questions that they couldn't have dreamt of before they had the platform that we gave them. Part of that platform and part of that ethos is also giving back to the community. And so we choose to open source many portions of our platform, some of them you see here, that address specific needs that we feel in the data science community in attempting to push what we call open data science across the community. And so that's a little bit about Two Sigma.
Excellent. And let's talk a little bit about that modeling platform. So we talk to, obviously, a lot of asset management firms, but a lot of Fortune 500 and Global 2000 companies around the world. And what we find is there's these key components that they end up building as they start to bring this in-house, as they start to really level this up and enable their modelers. Some components like data management are very obvious. You obviously can't do any modeling if you don't have any data. Others are things like being able to model itself. You are using Jupyter notebooks and scikit-learn, or using TensorFlow or PyTorch, whatever it may be. The middle part here, and this is the part that I'm going to focus a lot of the talk on, is the experimentation aspect. So if you're doing modeling to get the most out of it, you need to be able to do experimentation, trying different architectures, trying different models, different hyperparameters, feature embeddings, whatever it may be. You obviously need some compute stack in order to able to train and run these models. And then finally, you need to be able to deploy them so that you can hopefully get some business impact. And as you're thinking about different components and what you want to use for open source, what you want to build in-house, what you might want to procure from a vendor, there's a couple of key considerations that we see a lot of firms working through. So whether or not the solutions are existential to the firm itself, and a lot of domain expertise and contextual awareness is required in order to get the best possible performance or the best possible impact from it. So obviously, for an asset management firm, there's a lot of IP tied up in the trading strategies themselves. Certain aspects of like the hardware platform can be relatively commoditized. Obviously, that's been done with the clouds over the last several years. And finally, the model production aspect of it is something that is usually bespoke to a very specific application. Are you doing it on an edge device? Do you need to do high-frequency trading? What exactly do you need to do to get your model out there and producing the most business impact? But there's a couple of components that can be relatively standardized across a stack. Things where domain expertise don't necessarily lend specific benefit, orthogonal solutions, as Matt talked about a second ago, and things that can add incremental performance to this underlying system, letting your modelers run faster and really amplifying the edge and the gain that they have. So for some of the areas where it's commoditized or you bring domain expertise, we see a lot of firms building internal modeling platforms. I'm sure this is happening at a lot of the firms that you work at. But for aspects such as experimentation and model optimization, this can be an orthogonal problem that bolts on top of that bespoke platform and provides a big edge and level up to your modelers in general. And this includes things like being able to have insights and tracking, taking experimentation from in someone's head, or maybe a cobbling together of different standard brute force approaches or open source approaches and putting it behind a scalable interface. This includes having a strong optimization engine in order to be able to confidently know that you're getting the best results, and really unlocking more sophisticated methods and being able to ask completely different questions like Matt was talking about before. So this is exactly what SigOpt does. Having 3 pillars to our optimization and experimentation platform, an optimization engine itself that's peer-reviewed and patented, cobbling together and ensembling the best of Bayesian and global optimization techniques, an insights platform to be able to get you as much information as you possibly can get about the underlying models you're tuning, whether they're a proprietary trading strategy or a deep learning model, and finally doing this at enterprise scale. So a lot of our firm, a lot of our research engineers have developed a lot of the open source out there, from the metric optimization engine that I wrote while I was at Yelp, to SigOpt or SMAC or some of the other things that SigOpt employees have written. But the idea behind SigOpt is not necessarily to produce open source to publish a paper and then maybe move on, but to build an enterprise solution that can be trusted by some of the most leading and cutting edge firms in the world, whether that's 2 Sigma or some of our other customers. And the reason why this is really important is all of your modelers are doing experimentation, whether they're tracking it or not, whether they're doing a brute force approach or not, or whether they're leaving value on the table by just doing it manually. And the problem is, this is an extremely difficult problem to do. So imagine every single time you wanted to get a model, you had to go into this cockpit here and tune and tweak all of these different parameters. This represents all the hyperparameters, architecture parameters, feature embedding parameters, anything that you have to tune, all the magic numbers that actually make these systems work, and the things that you need to set before you pipe in that first piece of data. And the worst part is, every single time you change the data set, change the model, do some feature engineering, basically every single time a data scientist does their job, you need to do this again. And so there's a bunch of different ways that people call this. Traditionally, it's hyperparameter optimization, tuning the parameters of the model itself. So again, not replacing something like stochastic gradient descent, but tuning the parameters of stochastic gradient descent itself. And there's a lot of different things people call this: model tuning, model selection, neural architecture search, hyperparameter search. There's a lot of different methods out there for it, from evolutionary algorithms to Bayesian optimization methods, grid search and random search, or new variants of random search like hyperband have become really popular lately. But the idea behind this is there's a lot of different ways to do it. There's a lot of different things that people call it, but everybody has to do it. So I'm going to walk through a couple of different approaches that we see when we go out and talk to our customers that we typically find, and kind of pros and cons to each of them. And depending on what you're doing, one of these might be a great solution for you. But if you're doing advanced modeling like 2 Sigma, we'll talk about how a platform can help scale that up across an organization. So one of the most typical approaches we see when we see people doing this is manual search. This is akin to trying to do 10-dimensional optimization in your head, something humans aren't traditionally very good at. At best, they find local solutions. If I told you to find the right knobs and levers of a 10-dimensional system, it might take you a very long time to do that or build any intuition on it. And worse, what we often see is, again, by changing the data set, model, or whatever it is, a lot of the intuition that you built up might not transfer to that next problem. I gave a talk a few weeks ago at GTC where we took ResNet to do an image classification, kind of simple data set, simple model, pre-tuned on ImageNet, and then when we applied a different data set to it, the ideal hyperparameters shifted pretty dramatically. So even if you had spent a lot of time understanding ResNet, understanding ImageNet, understanding image classification, once you applied a different image classification data set to it, all of a sudden all that hard-won knowledge no longer translates into the peak performance. So to get away from this and to spend less time and energy and expensive data science and machine learning resources on this, people sometimes turn to things like grid search. This is exhaustively trying configurations and can work pretty well if you're tuning 1 or 2 parameters. So if you're tuning like a random forest or something like that, but quickly doesn't start working once you start to scale up the complexity and sophistication of your models. Even once you get to something like gradient-boosted decision trees and there's 5 or 6 dimensions, all of a sudden the exponential penalty you pay for doing this starts to really hurt you. So this is why a lot of times in the academic community, people have shifted over to random search. There's some great papers showing how this is, in expectation, strictly better than grid search. But this is akin to trying to climb a mountain by jumping out of an airplane and just hoping you land at the peak, and then getting right back in the airplane, ignoring whatever information you learned, and jumping back out again. And there's different approaches to make random search just a little bit more efficient, like early termination and successive halving or hyperband and things like that, but they all boil down to just doing random things and hoping you get lucky. And this, the probability that you get lucky decreases really dramatically as, again, the sophistication of these systems goes up, the dimensionality goes up, et cetera. So there's been a lot of work that's been going into things like evolutionary algorithms. Google has made a lot of noise in this space and gotten some really impressive results here. This can be great when you have specific types of architectures that you're tuning, and you can express your system in a way that allows you to do this more treed or evolutionary strategy. But unfortunately, it still requires a ton of resources. And if you look into some of these papers, sometimes hundreds of thousands of GPU and TPU hours went into doing evolutionary search. Because at the end of the day, it's relatively inefficient and requires a ton of sampling in order to converge to a result. And then there's been a lot of work in the academic community around Bayesian optimization, or more intelligent sequential model-based optimization. This can be an extremely efficient and effective way to get to the best results for your models. And we've shown in many empirical studies, and other labs have shown in many empirical studies, that it can get to better results much quicker than any of these methods. Whether it's manual search, grid search, random search, or variants of random search like hyperband or evolutionary algorithms. So what SigOpt represents is a way to take the best of these, ensemble them, and optimize them for you so that you don't have a problem that needs optimization and turn it into an optimizing the optimizer problem. And we do this very simply. So we bolt on top of your modeling stack, regardless of what that is. Maybe, again, it's traditional machine learning or deep learning, an algorithmic trading strategy, really anything where you can express tunable parameters. This is what I can configure about my system, from continuous parameters like a learning rate, integer parameters like the number of hidden layers or a batch size, all the way to categorical parameters like which stochastic gradient descent method should I use or which activation function should I use. So you define that. We suggest specific configurations for you to evaluate. You evaluate them, report back one or more objective metrics with or without noise, and then we learn from that with our optimization ensemble. We trade off exploration versus exploitation. We want to learn as much as we can about that underlying system and exploit that knowledge to drive you to better results. And what this means for you is an effective and efficient black box optimization method that never needs to look at your underlying model or data. All that's passed to us is the configuration space and the response that you care about. And that's defined as business impact. So again, not making assumptions that you're tuning for log loss or some academic metric that has nice asymptotic properties for proving theorems, but really saying, how do you, potentially as 2 Sigma, make the most money? How do you get the most impact out of what it is that you're trying to drive towards? All through a simple REST API.
That sounds so good. I want 2.
Perfect. Well, you've already got 1.
So, as a growing company, one of the questions that we face, that everyone faces, is do we build or do we buy? And at 2 Sigma, we choose to actually ignore the question, because one of the key tenets that we have is that we try and take a 360-degree view of the market or the problem we're trying to solve. And I think one of the key learnings that I've had over the 15 years I've been at 2 Sigma is there is almost always someone cleverer than me out there. Usually there's always someone cleverer than me in the room. And what I want to do to create a successful business is leveraging them, right? It's great to hire smart people. At 2 Sigma, we hire very smart people, and we're hiring. But it's even better if I can get smart people to work for me and they don't even know it. And we can't have the expertise of everything in the world, especially in the problem set that we do. So our problem set is a very vast one. You have to go from ideation, so someone has to kind of think of some great idea of in some liquid markets that they believe might be profitable. They have to then find the data, so there's a bit of investigation to figure out what data I might need to prove or disprove my hypothesis. Then I have to go and actually get the data, so I need some negotiation tactics there. I've got to get it into the company. It's usually a large amount of data, so I need a lot of platform to be able to bring it in, store it, access it, or give access to it to my modelers, who then have to do analysis on the data, figure out if indeed this data set is even complete and if it's clean before they even think about whether it actually fulfills the hypothesis they're trying to test. Then they actually have to create the model. We have simulations and backtests and things like that, so they can figure out whether the model may or may not be profitable, and then eventually we might trade it. And somewhere along that vast amount of work they need to do is optimization, which, as Scott just very briefly walked through, is a huge, mile-deep trench in and of itself. And so finding people who can span that gamut and not be an inch deep, be more than an inch deep, is virtually impossible. And in fact, it's kind of a Sisyphean task to find those people. And so it was great maybe 15 years ago when things were simpler, right? Low-hanging fruit was around in investment management and quantitative investment management. The algorithms that we're using were fairly simple. And in fact, it's kind of interesting that the examples of algorithms that Scott just put up on the previous slide kind of looks like a history of 2 Sigma. We started off with manual search. That was pretty good. We got far with that. But then we realized we have multiple dimensions. We moved on to grid search. We got frustrated. We then went to look at the literature, and we found that there were some really cool ways to do better than grid search. We skipped the random search, but we did a lot of annealing at one point, so it's half random search. We've got some evolutionary algorithms floating around, and Bayesian optimization. So we've done little bits of all of these, and just enough to realize that we just are not experts. And so when we come to the notion of build or buy, we think about building and buying. Right? There is sometimes a proprietary advantage to DIY, maybe not as much as we think. So we have to kind of write down the hypothesis. What is it? Do I want to spend the dollars that I've got on understanding Bayesian optimization, or maybe understanding some other portion of this modeling life cycle? Am I going to benefit from the domain expertise? If I hire someone who's an expert in Bayesian optimization, they might solve today's problem. Am I going to want them to solve tomorrow's problem, next year's problem? How am I going to keep them up to date in Bayesian optimization when we're an investment manager? Is it going to be identical? Am I going to be able to deploy these people or these algorithms all the time in the same fashion, or am I going to, getting myself into a real mess here by having to have a whole stable of algorithms, all of which has to be looked up. And maybe I'll open source them and get the whole world to help me in that, or maybe I'll find them in open source. But then I still have to be able to build a platform. And so those are all the kind of things that go through our minds when we're thinking about, do we build, do we buy, do we do both? We build a little bit and buy a little bit more. And that is one of the reasons we came upon SigOpt, was, in fact, in exactly the previous slide, was this beautifully clean approach to the problems that we're trying to solve. So we have algorithms, or we have models that we want to optimize, and we want to expose those hyperparameters, but we are very cautious about the intellectual capital that we have. We don't want that to go out. And so we really want someone who will just take the knobs on the outside, plus an understanding of how close I am to my goal, and just give us the results back. And I think one of the aha moments for us as we were looking around at the availability of tools like those that SigOpt provide is the kind of very clean and fairly anonymous interface that they provide in order to complement the suite of tools that we've built in-house, so that number one, we can check ourselves, number two, we can check them, and we can have a party together. So that was kind of the methodology that we went through to think about how we get involved with SigOpt.
Excellent. So again, the high-level takeaway here is making sure that you can help realize the benefits, and that's these performance gains, which matter a lot for a firm like 2 Sigma. Being able to address entirely new problems, so being able to say, okay, maybe I was artificially constraining myself because the only tool I had in my tool chest was something like grid search and random search, so I didn't decide to try that new neural network or that new architecture, whatever it may be. Or worse, maybe you did try it, but you didn't tune it, and so you said the untuned random forest beat the untuned neural network, but you didn't realize that by doing a little bit of hyperparameter optimization or architecture search, that neural network could far surpass even a tuned random forest. And so it led you down to this kind of suboptimal rut in model space itself. And then at the end of the day, you also want to be able to maximize your resource utilization. So obviously, waiting for that exponential, for that grid search, or sequentially going through things with a traditional Bayesian optimizer doesn't necessarily use everything that you have. So we're going to walk through a specific case study that was published last week on 2 Sigma's website, and Matt's going to walk through these 3 value propositions that we were able to prove out when working with them. Again, the idea is, as you're building these modeling platforms, think about, is this something that lends me expertise, and do these benefits speak to what my modelers can use? So we've done a lot of different case studies with NVIDIA and AWS and a lot of our other partners that are available online that go into a lot of depth about very specific improvements, orders of magnitude faster than these traditional methods, et cetera. But for 2 Sigma in particular, they weren't, again, using some of the more naive methods. They were using some of these more sophisticated methods that they had taken from the literature, from the open source, built in-house, et cetera. And when they compared us, they saw some pretty great results. And I'll pass it off to Matt to talk a little bit more about that.
So you've got the requisite quote. By the way, everyone at 2 Sigma is called Matt. Look, we spent a fair amount of time over the years creating and getting an understanding of the literature, creating the algorithms from the literature, and just understanding stuff that we just didn't even know existed as we began to scratch the surface and dig deeper. We had a variety of platforms that had developed, but at the same time that we were trying to do hyperparameter optimization, we were also driving the whole platform forward. And so we were, wanted to get to where we could use elastic compute, where we could integrate fully both with cloud vendors as well as have our own proprietary systems. And what was happening was that in that optimization, which was, maybe we used where we used random search to optimize the work that we were doing, we found that we were falling further and further behind in getting expertise here. And so while the results were good, they weren't amazing. And we only found that out when we kind of got together with some of the experts to actually have a look. And for us, this is really important because at the end of the day, we're an investment manager. And so our goal is to bring our tools to bear on investment management to create models that take part in the liquid markets. And the more models that we can get out, the better chance we have of success. And the more models, the more time we have to focus on modeling and not on some random or grid search, the more time we will have to kind of think up new hypotheses and get them out faster. And it was quite a surprise to us, I should say, initially. We've improved our own internal platforms as a result, but it was quite a surprise to us initially when the first results were basically an order of magnitude. And now when you have things that complete in an order of magnitude, you can ask a lot more questions. And that was really the key, the kind of aha moment to us, and I alluded to that when I was talking about the platform earlier, is that suddenly you can ask questions that you didn't dream of before. So suddenly you can go to your models and say, wait a minute, every time I've used a number in those models, whether an integer or a float or whatever, I'm implicitly choosing a hyperparameter. I wonder why we did that. And we could turn SigOpt onto things that had 8, 10, 12, 15, 20, or more hyperparameters, and not just in modeling, by the way. I turned this on the JVM configuration as well to see if maybe we could get better. We used it in order to understand the resources that we were using internally. So there are many, once you understand it, you can just turn a knob and get a result fairly quickly. There are all sorts of questions you can ask. In fact, I'm going to take an aside here and tell you what sold me on Scott and the company. In one of our earliest meetings, I said, well, what have you optimized? It's kind of interesting. Like, what do you optimize? Like, just kind of give me some examples. I know what we're optimizing. So Scott told me, was it Anheuser?
Miller Coors.
Miller Coors. He says, well, we optimized the brewing process for Miller Coors. I'm like, wait, what? I can't believe that they have a farm of machines that, no, they're actually real knobs. But because you have this beautiful and very simple to use REST interface, they could actually take literally the outputs of the knobs and try and improve the brewing process. And that, for me, was a real eye-opener, because it meant that you can ask questions suddenly that you didn't think there was even an optimization process behind, because you never really thought about it. And so that enabled us to think and use SigOpt for all sorts of experiments, that some of which don't have much to do with our core business of modeling, but they do have a lot to do with our core business of business. And the speed at which the results are returned allow us to have a better conversation with our models and a richer information content as a result. So better results faster.
Definitely. And you can read in the blog how they got those benefits by switching from random search to, in the case that we were comparing against here, open source like gPyOpt, and then got another benefit by using SigOpt on top of that. So even if you're using some of the open source, there can still be orders of magnitudes of improvement left on the table. There's a lot of things that go into solving this for real enterprise problems as well. This is one of the things that we found different from some of the open source that me and some of the research team had published, where it was a very narrowly defined problem that was very good at solving pathological problems from the academic literature, which is great if you're a grad student and trying to publish papers, which I was at the time. But when you go into real world problems, all of a sudden the problem starts to get a lot harder. There's all these edge cases. There's all these things that you don't take into account when you're trying to prove a theorem or show something converging asymptotically. It can be everything from the system can just fail arbitrarily for different reasons. You might have a lot of extra constraints. Maybe they're not nicely phrased linear constraints. Maybe they're complete black box constraints. The data itself can be pathologically noisy. There might be different competing metrics that you're trying to trade off. You're not just shooting for one thing, but you want to even see what's feasible and see how you can efficiently trade those two things off. It might take a really long time in order to evaluate something, so you need to be able to efficiently subsample smaller versions of the task. Or you might need to be able to leverage a large computational infrastructure, because you can't do this sequentially. You need to be able to do dozens or up to 100 different configurations simultaneously. So I'll dive into one here real quick that was in the use case and hand it back over to Matt. But this was something that they found to be especially useful. Or this one.
So, I think life is hard. We kind of don't realize sometimes how hard life is. But life is pretty hard. And one of the problems that we have at Two Sigma is a fairly straightforward one, which is that to get an answer to my question as to whether my model is successful may take a really long time. And time really is money in this day and age, right? It's about compute resources. That's the time we're thinking about. And maybe more importantly, the time of the modeler, because human time is even more valuable than compute time. They could be doing something else with their brain. And so it's tough. You have to kind of go through this process where you run a very long back test, you wait for a long time, and then you get a result. And unfortunately, in the business that I'm in, the result is almost never yes or no. And I think that alludes to something that Scott said earlier. Sometimes I see people talk about kind of N sigma events, 6 sigma events, and they say like, this is the storm of the century, it's a 6 sigma event, or it's roughly, you get a 6 sigma event once in every 500 million. People are like, oh man, something must have happened. But actually, if you ever see someone say there's a 6 sigma event, then what they're really telling you is that the underlying distribution that they're choosing from is not normal, because there's an assumption in that statement about 6 sigma is that everything is normal and therefore nice and Gaussian, right? But life is not like that. My business in particular is fraught with constraints. And those constraints take what might be log normal distributions and just send them all over like just completely crazy. And so what we do is we end up having multiple different metrics that judge in different capacities whether the simulation that I'm running is successful. But now, it's what's that thing in math, the Banach-Tarski paradox? Now I have an even bigger problem, which is I've run a very long calculation, I have multiple competing metrics, and now I'm scratching my head saying, how do I figure out which one is better? And so one of the things that SigOpt has really done for us is by thinning out the number of experiments that I'm running, which is on the red, from the red to the blue, I'm actually able to think harder about which of those competing metrics are actually useful and which of those are less useful for my purpose by effectively pushing that efficient frontier of the optimization much clearer, as you can see in the blue, than it is in the red.
Excellent. And again, one of the benefits of having an enterprise platform here is the ability to have this be agnostic to the underlying model type. So as your modelers, as your engineers maybe move from more traditional machine learning to AI or start doing new reinforcement learning things or whatever it may be, they still have this problem. And we move right along with them. We work with firms that do a ton of decision tree-based modeling because they're in constrained industries that are highly regulated, all the way up to firms like Two Sigma that do all sorts of crazy things, or OpenAI that uses us for robotics and reinforcement learning applications. In addition to that, you need it to be reliable, especially if money is changing hands. Two Sigma has over $50 billion of assets under management, and it really matters to them to make sure that things are reliable. And so obviously having an SLA is very different than having open source that might throw an error for any arbitrary reason. And finally, being complete and attacking some of these real enterprise problems that you have is necessary to kind of drive your teams forward. Again, augmenting their expertise, amplifying that difference, and not replacing it is key to making sure that you can take what you uniquely bring to the table and making sure that that differentiated modeling goes quite a bit further. So I'll end here in 2 slides, but first the final value proposition from that use case and case study around being able to fully utilize compute.
Yeah, and so we spend a lot of time computing stuff, and so we have a fairly vast compute farm that has multiple different compute resources, different architectures, GPUs, TPUs, CPUs, as well as different providers. We have spent many moons attempting to create a fairly uniform compute resource that can be at the beck and call of all of our modelers, but it costs to have such a resource. And so one of the things that's uppermost in our mind is really, are we utilizing our resources effectively? And one of the things that SigOpt has helped us understand is how we can use this completely asynchronous parallelization to help balance out our resource utilization. And so, I think what I would say is that it maybe sounds too good to be true, and that would be wrong of me to leave you with that idea. I think that SigOpt has been an incredible piece of the platform that we've been building for 15 years. It's allowed us the leverage to see things and to understand things we couldn't, which is what the platform was all about. It's allowed us to focus our expertise in areas that otherwise we would have had to load balance with understanding Bayesian optimization, amongst other things. And it's allowed us to balance the utilization of our resources across the whole platform. And so it's been a great member of the family in that sense.
And this can help no matter where you are in your modeling stack. We work with firms of various levels of sophistication. Obviously, Two Sigma is at the bleeding edge of a lot of this, and they care a lot about performance. And it's really about driving to that best result and using these resources as efficiently as possible. We work with other firms that have just bolted us in across the board in their modeling platform. And by getting incrementally better results across the board, that rising tide leads to very massive business impact, as well as firms like global technology consulting firms that are doing a lot of exploration. And for them, it's how do I get to an answer as quickly as possible? How do I spend 2 less weeks doing model selection or doing tuning and tweaking by hand in order to get to something great that I can hand off to my clients? And so again, if you're exploring, if you're scaling, or if you're extremely performance driven, this is a necessary tool to make sure that your teams are fully leveraged. Which leads to happy engineers, which I know Two Sigma is hiring.
These are pictures off the Two Sigma website, so these are all actually Two Sigma engineers. We kind of have fun. We believe that people move the business, and if you believe that, you invest in people, and that's what we do at Two Sigma. We hire the best, and then we set them to solve really hard problems, which they do with alacrity, and help deliver value for the business. So it's all one big happy family.
Excellent. So if you're interested in trying SigOpt, we've got a booth in the expo hall. We have a bunch of people who would love to talk to you and help get you set up. If you're a student, we have an academic program that gives access to our enterprise software completely for free. Over 100 universities around the world use us and various national labs. So if you're doing peer-reviewed, publishable research, we'd love to just cut some time out of that. I wasted way too much of my PhD on this problem. We'd love to help accelerate you. But for businesses looking to really accelerate their platforms, really amplify that edge that their modelers have and make them more efficient and get better results, we'd love to talk to you and see if we can help with that. So thank you all.